Welcome back to Josh Does Math. In this video we're going to be using implicit differentiation, which whenever you see the words implicit differentiation, that means don't try to isolate y, just take the derivative of both sides, and then try to isolate dy dx later. So that's what it means. You're looking at a function that's defined implicitly. See how y isn't isolated already, it's just in there somewhere? That's what implicit differentiation is. We're just taking the derivative of this whenever y is mixed in with all of our x's. So if we were to take the derivative of this implicitly, we take the derivative of both sides, and as you can see, the left side is a bunch of terms, so we're just going to be taking the derivative of those terms individually. So d3x to the third dx plus d4y to the third dx plus d8 dx is equal to d0 dx. And I just wrote all those derivatives in there, although a lot of them can be simplified even without writing this first step, just so that you can see how this is working. So I'm going to start with these terms over here. d0 dx is 0, so is d8 dx. Those are just constants. How about this term over here? Well, I'm going to pull the 3 out front. That's the constant multiple rule. And then I'm going to pull the power out front and make it one smaller. That's the power rule. How about this one right here? Well, I know I can pull the 4 out front. I can also use the chain rule to write the rest of it as dy to the third dy times dy dx. And as you can see, we finally have our dy dx that we're looking for. So now all that's left is to solve the remaining derivatives and rearrange for dy dx. So this becomes 9x squared plus 4, what's dy to the third dy? That's going to be power out front, one smaller on the power, times dy dx is equal to 0. And now we're just rearranging for dy dx. So I'm going to subtract 9x squared from each side. And then I'm going to divide by 12y squared. And I also divided by a factor of 3 in the top and bottom here. So this is what you're left with. And as you can see, we end up with y in our final answer, which for implicit differentiation, that's usually okay. Sometimes you'll be asked to actually solve this equation for y. If so, we would get cube root of something, and then you would plug that in for every y down here. But usually this is just okay for implicit differentiation because sometimes it's actually impossible to solve for y, so you're forced to involve y in your final answer here. But that's how you take the derivative of this equation with implicit differentiation. Thanks for watching.